thinking that you can interface the memory with 8051, thinking that you know how to interface the RAM and the ROM to 8051, I'm going to skip that particular topic. If you all want that particular topic also, then just send me the message in the group that you need that particular interfacing of the memory to 8051. I'm going to take the example of one in the ROM and one in the RAM, and then I'm going to send it to you all. So now the most important wherein you started facing the problem is about the addressing modes and the programming techniques of the 8051. So that means I'm going to say over here today about the addressing mode with respect to 8051. See, while explaining about the block diagram of the microprocessor, or it may be about the microcontroller, always one thing you should have in mind: the CPU is always going to have the interaction with the memory. Without memory, the CPU is not going to do anything. So that means always the interaction with the memory. So the way how the CPU is going to access the data from the memory, the way how the CPU is going to access the data, memory in the ಯಾವ ರೀತಿ ಒಳಗೆ ಡಾಟಾನ ಆಕ್ಸೆಸ್ ಮಾಡ್ಕೊಳ್ಳಿರುತ್ತದೆ, that is going to be called as the addressing mode. That is going to be called as the addressing mode. Maybe microprocessor or it may be the microcontroller, the definition remains the same. The addressing mode is going to say about the way how the CPU is going to access the data from the memory. It may be the RAM or it may be the ROM, whatever it is going to say how it is accessing. This particular, depending upon how the data is being accessed from the memory by the CPU, we are having 5 addressing modes in 8051. We are having 5 addressing modes in 8051. What is that? Say the first one, the easiest one, that is the register addressing mode. Register addressing mode. And then you're going to have, say, immediate addressing mode. Register addressing mode, immediate addressing mode, and then you're having direct addressing mode, and then indirect addressing mode, and then you're having indexed addressing mode. These are the 5 addressing modes which are present in 8051. Register addressing mode, immediate addressing mode, direct addressing mode, indirect addressing mode. ಕೆಲವೊಂದು ಬುಕ್ಸ್ ದೊಳಗಿದು ರೆಜಿಸ್ಟರ್ ಇಂಡೈರೆಕ್ಟ್ ಅಡ್ರೆಸಿಂಗ್ ಮೋಡ್ ಅಂತಲೂ ಬರೆದಿರ್ತಾರೆ. That is also correct. And next one is going to be indexed addressing mode. So these are the 5. And on this particular topic, 100% you are going to have a question asking define any 2 of the addressing modes, list the addressing mode, explain the addressing modes with example. Part A ದೊಳಗೂ ಬರ್ಬೋದು, part B ದೊಳಗೂ ಬರ್ಬೋದು, but this particular topic is going to be the most important one, wherein don't by heart it, understand and then write that particular definition of the addressing mode in your own words. I have seen ನಾ ಏನು ಅಸೈನ್ಮೆಂಟ್ ಕೊಡ್ಲಿಗತ್ತೀನಿ, ಅದು ನಾ ಏನು ನೋಟ್ಸ್ ಕೊಟ್ಟಿನಿ ಅದರದ್ದೇ ಡುಪ್ಲಿಕೇಟ್ ಅದ. ಹಂಗೆ ಮಾಡ್ಲಿಕ್ಕೆ ಹೋಗ್ಬೇಡ್ರಿ. ಯು ಲರ್ನ್ ಇಟ್, you think on your own and make your own sentence and write that one, right? It must be precise. ಒಂದು 2-3 ಸರ್ತಿ ನೀವು ಬರೆದ್ರಿ ಅಂತಂದ್ರೆ ತಾನೇ ಬರ್ತದೆ. Okay, now these are the 5 addressing modes in 8051. First we'll deal with the register addressing mode. Okay, so here in the register addressing mode, ಇದನ್ನು ಹೇಳೋದಕ್ಕಿಂತ ಮುಂಚೆ ಯಾವುದು ಅಡ್ರೆಸಿಂಗ್ ಮೋಡ್ನ ನಾನು ಡೀಟೇಲ್ ಆಗಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡೋದಕ್ಕಿಂತ ಮುಂಚೆ instruction format ಹೆಂಗಿರ್ತದೆ, 8051 instruction format, how it is going to be, I'm going to say that now. Say you're going to have the opcode, different fields in an instruction, that is opcode, and then you're going to have the operand. These are the 2 fields in the instruction, opcode field and then the operand field. In the operand field, again you're going to have 2 sub fields. One is the source and then another is going to be the destination. Opcode, operand. In the operand you're going to have the source and then you're going to have the destination. So how the format will be, it is going to be opcode and then you're going to have the destination field separated by a comma with the source field, opcode. What is this opcode? Operation code. See, we are going to use over here in the 8051 first what is that, assembly language program, and then we are going to see the embedded C. In the assembly language programming, we are going to use English like words which are going to be called as the mnemonics, which are going to say what operation is going to be performed on the data which are fed in the source and the destination. So opcode field is going to say what operation is going to be performed, and operand ಅಂದ್ರೆ ಯಾವುದರ ಮೇಲೆ ನಾನು ಆಪರೇಷನ್ ಮಾಡ್ತೀನಿ ಅದಕ್ಕೆ ನಾವೇನಂತೀವಿ ಆಪರಾಂಡ್ ಅಂತೀವಿ, right? So the operation is going to be done on the source and the destination. It all depends what type of operation is being performed. So the operation is going to be done on the operands. Okay, so this is going to be the very basic instruction format of 8051. You're going to have the opcode, you're going to have the destination, and then the source. Both are going to be separated by a comma. Now, in front of the instruction, if you want to write any comment, then the comment should begin with a semicolon, saying that the comments are not the part of the instruction. You can write the comments. You're going to write the comments. It should start from the semicolon. Suppose if you want to give any label to the instruction, then write the label and then separate it with the opcode by a colon. So label is a name. It is a user defined name. It should not start from a number. It should start from an alphabet. It can be the combination of numbers and the alphabets and the symbols, but it should not start from a a number or a symbol. It should start from an alphabet. And what is the maximum length? It should be 8 characters. Okay, so like this the condition is going to be. So this is going to be the instruction format. Now with the help of this particular instruction format, how the CPU is going to access the source from the memory, or how it is going to move it from the memory to the CPU, the way is going to be called as the addressing mode. Okay, so now we'll go for the first type of the addressing mode. What it is register addressing mode. In this particular register addressing mode, you're going to have the opcode. ಅಂದ್ರೆ ಯಾವ ಆಪರೇಷನ್ ಇರ್ಬೋದು, ಬರೀ ಡಾಟಾ ಮೂವ್ಮೆಂಟ್ ಇರ್ಬೋದು, ಅರ್ಥಮೆಟಿಕ್ ಆಪರೇಷನ್ ಇರ್ಬೋದು, ಲಾಜಿಕಲ್ ಆಪರೇಷನ್ ಇರ್ಬೋದು, ಅಥವಾ ಬ್ರಾಂಚಿಂಗ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್ ಇರ್ಬೋದು, ಏನೇ ಇರೋದಕ್ಕೆ ವಾಟ್ ಆಪರೇಷನ್ ದಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ said over here in the opcode, operation code. And after that, I said you're going to have the source and then you're going to have the destination. Both are going to be separated by the comma. Now, in the place of the source, you're going to use the working registers. So here, this is going to be a register, and in the destination place also, you're going to have the register. If in the source field and in the destination field, you have the registers. If you have the registers, the source is also a register and the destination is also a register, then I'm going to call that type of addressing mode as the register addressing mode. ಎರಡು ಕಡೆ registers ಇದ್ವು ಅಂತಂದ್ರೆ ಅದು ಎಂತ type addressing mode ಆಯ್ತು? register addressing mode ಆಯ್ತು. Now this is the easiest way. ಒಂದು register ಇಂದ ಇನ್ನೊಂದು register. ನಮಗೆ ಇಲ್ಲಿ ತನಕ ಏನು ಗೊತ್ತಾಗಿದೆ? ನಮ್ಮ ಹತ್ರ ವರ್ಕಿಂಗ್ ರೆಜಿಸ್ಟರ್ಸ್ R0 ಇಂದ R7 ತನಕ ವರ್ಕಿಂಗ್ ರೆಜಿಸ್ಟರ್ಸ್ ಅವ. ಓಕೆ, ಅಕ್ಯುಮುಲೇಟರ್ ಅನ್ನೋದು ಒಂದು ರೆಜಿಸ್ಟರ್ ಗೊತ್ತಾಗಿದೆ, ರೆಜಿಸ್ಟರ್ ಬಿ ಅಂತ ಗೊತ್ತಾಗಿದೆ. PCR ನಮ್ಮ ಕೈ ಒಳಗಿಲ್ಲ, ಅದು ಸೀಕ್ವೆನ್ಷಿಯಲ್ ಎಕ್ಸಿಕ್ಯೂಷನ್ಗೆ ಹೆಲ್ಪ್ ಮಾಡ್ತದೆ. ಇಟ್ ಹೋಲ್ಡ್ಸ್ ದ ಅಡ್ರೆಸ್ ಆಫ್ ದ ನೆಕ್ಸ್ಟ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಟು ಬಿ ಎಕ್ಸಿಕ್ಯೂಟೆಡ್ ಇನ್ ದ ಪ್ರೋಗ್ರಾಮ್. ಅಂಡ್ DPTR, ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಯೂಸ್ ಟು ಹೋಲ್ಡ್ ದ 16-bit ಡಾಟಾ. ಓಕೆ, ಸೊ ಇವಿಷ್ಟು ನನಗೆ ರೆಜಿಸ್ಟರ್ಸ್ ಗೊತ್ತಿರಬಹುದು ಈಗ ಸದ್ಯಕ್ಕೆ. ಓಕೆ, ಇವು ಅಂದ್ರೆ ಏನು, ಇಲ್ಲೇನು ರೆಜಿಸ್ಟರ್ ಅಂತಂದ್ರೆ ನಾ ಈ ರೀತಿ ಬರಿತೀನಿ. ಸೇ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಲೆಟ್ ಮಿ ಟೇಕ್ ದ ಆಪ್ಕೋಡ್ ಮೂವ್, ಅಂದ್ರೆ ಇದು ಒಂದು ಡಾಟಾ ಟ್ರಾನ್ಸ್ಫರ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಅಂತ ಮೂವ್. ಸೇ ರೆಜಿಸ್ಟರ್ ಅಂದ್ರೆ R0 ಬರಿತೀನಿ, ಇಲ್ಲಿ R1 ಬರಿತೀನಿ. ಅಂದ್ರೆ ಅರ್ಥ ಏನಾಗ್ತದೆ ಇಲ್ಲಿ? ಮೂವ್ ಸೋರ್ಸ್ನಿಂದ ಯಾವಾಗ್ಲೂ ಡೆಸ್ಟಿನೇಷನ್ಗೆ ಹೋಗ್ತದೆ. ಅಂದ್ರೆ R0 ಅನ್ನೋ ರೆಜಿಸ್ಟರ್. ವಾಟ್ ಇಸ್ ದ ರೆಜಿಸ್ಟರ್? Register is a storage. It is nothing but the memory location. ಅದ್ರ ಒಳಗೆ ಏನೋ ಒಂದು ಡಾಟಾ ಅದೇ ಸೋರ್ಸ್ ಅದೇ ದಟ್ ಯು ಹ್ಯಾವ್ ಟು ಕಾಪಿ ಇಟ್ ಇನ್ ಟು R1 ಅಂತಂದ್ರೆ ಸೋರ್ಸ್ನಿಂದ R1ಗೆ ಡಾಟಾ ಮೂವ್ ಮಾಡು ಅಂತ ಅಂದ. This is correct now. You're having over here a register and you're having over here a register. This is going to be an illegal instruction. There is certain limitation in the register addressing mode. What it is, in the place of the source or in the place of the destination, in the place of the source or in the place of the destination, you should use accumulator. You should use accumulator. Without accumulator, between the two working registers, the data movement is not possible. What I am saying now, register addressing mode, in the register addressing mode, the source operand will be the register, destination operand will also be the register. You cannot take two working registers in the place of the source and the destination. What you have to do, either in the place of the source or in the place of the destination, you should have accumulator. ಒಂದು ಜಾಗದಾಗ accumulator ಇದ್ದೇ ಇರಬೇಕು. ಅಕ್ಯುಮುಲೇಟರ್ ಬಗ್ಗೆ ಹೇಳ್ಬೇಕಾದ್ರೆ ಹೇಳ್ತಿದ್ದೆ, ಡಾಟಾ ಮೂವ್ಮೆಂಟ್ ಈಸ್ ಆಲ್ಸೋ ನಾಟ್ ಪಾಸಿಬಲ್. ಒಂದ್ ಕಡೆಯಿಂದ ಇನ್ನೊಂದ್ ಕಡೆ ಡಾಟಾ ತಗೊಂಡು ಹೋಗ್ತೀನಿ ಅಂತಂದ್ರೂ ಏನ್ ಮಾಡ್ಬೇಕು, ಅದು ಎಲ್ಲದ ಅಲ್ಲಿಂದ ಅಕ್ಯುಮುಲೇಟರ್ಗೆ ಹೋಗ್ಬೇಕು, ಅಕ್ಯುಮುಲೇಟರ್ ಇಂದ ಎಲ್ಲಿಗೆ ಕಳಿಸ್ಬೇಕಾಗಿದೆ ಅಲ್ಲಿಗೆ ಕಳಿಸ್ಬೇಕಾಗ್ತದೆ. ಸೊ ದಿಸ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ದ ಇಲ್ಲೀಗಲ್. ವಾಟ್ ಮೇ ಬಿ ದ ಲೀಗಲ್? ಸೇ ಇಟ್ ಮೇ ಬಿ ಮೂವ್ A, R0 or it may be move R0, A. Like this you can have any instruction. So either in the place of the source operand or in the place of the destination operand, you should have the accumulator. This is the first limitation of the register addressing mode. The second limitation is the size of the two registers. ಯಾಕಂತಂದ್ರೆ ನಮ್ಮ ಹತ್ರ ಕೆಲವೊಂದು 8-bit registers ಅವ, ಕೆಲವೊಂದು 16-bit registers ಅವ. ಸೊ ಆ ಸೈಜ್ ಏನಾಗಬೇಕು, ಮ್ಯಾಚ್ ಆಗಬೇಕು. ಸೋರ್ಸ್ದೊಳಗೆ 8 ಇತ್ತು ಅಂತಂದ್ರೆ ಡೆಸ್ಟಿನೇಷನ್ದೊಳಗೆ ಎಷ್ಟು ಇರಬೇಕು, ಅದನ್ನು 8 ಇರಬೇಕು. ಓಕೆ, ಇದರೊಳಗೆ 16 ಇತ್ತು ಅಂತಂದ್ರೆ ಇಲ್ಲಿನೂ 16 ಇರಬೇಕಾಗ್ತದ್ರಿ. ಎಲ್ಲಿ ಸೋರ್ಸ್ದೊಳಗೆ 16 ಇತ್ತು ಅಂತಂದ್ರೆ ಡೆಸ್ಟಿನೇಷನ್ದೊಳಗೂ 16 ಇರಬೇಕಾಗ್ತದೆ. ಓಕೆ, ಲೈಕ್ ದಟ್ ಯು ಶುಡ್ ಹ್ಯಾವ್ ದ ಸೈಜ್ ಆಫ್ ದ ರೆಜಿಸ್ಟರ್ಸ್ ಇನ್ ದ ಸೋರ್ಸ್ ಆಪರಾಂಡ್ ಅಂಡ್ ಇನ್ ದ ಡೆಸ್ಟಿನೇಷನ್ ಆಪರಾಂಡ್ ಟು ಗೆಟ್ ಮ್ಯಾಚ್ಡ್. ಅವು ಮ್ಯಾಚ್ ಆಗಲಿಲ್ಲ ಅಂತಂತಂದ್ರೆ ಯು ಆರ್ ನಾಟ್ ಗೋಯಿಂಗ್ ಟು ಹ್ಯಾವ್ ದ movement of the data, because that is going to be the illegal instruction. So this is going to be the register addressing mode. Let me give the examples. ಯಾವಾಗಲೂ examples ನ ಕೊಡಬೇಕಾದ್ರೆ ಬರೀ ಡಾಟಾ ಮೂವ್ಮೆಂಟ್ ಇಂದೇ ತಗೋತೀವಿ, ಡಾಟಾ ಟ್ರಾನ್ಸ್ಫರ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್ ತಗೋತೀವಿ. So you are used to that. Let me write that one. Say move R0, A, R0 ಅಂದ್ರೆ R0 ಅನ್ನೋದು ಒಂದು ವರ್ಕಿಂಗ್ ರೆಜಿಸ್ಟರ್. ಅದು ಅದ್ರೊಳಗೆ ಏನದೆ, ಅದು ಡೆಸ್ಟಿನೇಷನ್ ರೆಜಿಸ್ಟರ್ ಯಾವ್ದದ, ಅಕ್ಯುಮುಲೇಟರ್ ಅದ, ಅಲ್ಲಿ ಕಾಪಿ ಆಗ್ತದೆ. ಇದನ್ನು 8-bit ರೆಜಿಸ್ಟರ್ ಅದ, ಇದನ್ನು 8-bit ರೆಜಿಸ್ಟರ್ ಅದ. ಡಾಟಾ ಮೂವ್ಮೆಂಟ್ ಈಸ್ ಪಾಸಿಬಲ್. ಆರ್ ಎಲ್ಸ್ ಐ ಕ್ಯಾನ್ ರೈಟ್ ಲೈಕ್ ದಿಸ್, ಮೂವ್ A, R6 ಅಂತಂದ್ರೆ ಏನರ್ಥ, ಅಕ್ಯುಮುಲೇಟರ್ ಇಸ್ ಅ ಸೋರ್ಸ್ ನೌ ವಿಚ್ ಇಸ್ 8-bit. R6 is the destination which is also 8-bit. So data whatever is there in the accumulator will get moved, will get transferred, will get copied into the 8-bit working register R6. 8-bit working register R6. Or else I can have like this, move see if I write like this, one ತೋರಿಸ್ತೀನಿ ನೋಡ್ರಿ, move A, DPTR ಅಂತ ಬರೀತೀನಿ. ಏನಾಗ್ತದೆ, ಇದು ಇಲ್ಲಿಗಲ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್. ಯಾಕೆ, DPTR ಅನ್ನೋದು 16-bit ಅದು, ಅಕ್ಯುಮುಲೇಟರ್ ಅನ್ನೋದು 8-bit ಅದು. ಯು ಕೆನಾಟ್ ಹ್ಯಾವ್ ದ ಡಾಟಾ ಮೂವ್ಮೆಂಟ್. ಸೊ ದಿಸ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ದ ಇಲ್ಲಿಗಲ್ ಅಂತಂದ್ರೆ ಇದು ಅಲೌಡ್ ಇಲ್ಲ, ಇದನ್ನ ಮಾಡ್ಲಿಕ್ಕೆ ಬರಂಗಿಲ್ಲ. ಯಾಕಂದ್ರೆ ಇದ್ರೊಳಗೆ 16-bit ಇಂದ ಜಾಗ ಇದ್ರೊಳಗೆ ಬರೀ 8-bit ಇಂದ. ಯು ಕ್ಯಾನ್ ನಾಟ್ ಕಾಪಿ 16-bit ಡಾಟಾ ಇನ್ 8-bit register. So this is going to be about the register addressing mode.